Welcome back to Math with Miss Swartz. Today we are going to be looking at reflections. Reflections are a little bit different than translations. Translations, remember, we were sliding a congruent figure across the coordinate plane. A reflection, the word we want to think about when we see reflection is flip. We're going to flip a congruent figure across an axis. So we're going to be working specifically with flipping it across the x-axis and across the y-axis. So first thing we need to do is figure out, okay, what does a reflection look like? Can we recognize a reflection? So here we go. Yes, you do need to write this down. Okay? You don't have to draw the picture. Trying to be very clear about what you need to write down and what you don't. Write down the words, write down the algebra, write down the fact that they are congruent. Okay? So to reflect a figure in the x-axis, take the opposite of the y-coordinate. We did this with the points. We reflected points. To reflect a figure in the y-axis, take the opposite of the x-coordinate. So it gives you a picture here. Reflection in the x-axis. Wherever your point is, you're going to make the y-coordinate its opposite. And then if you're doing it across the y-axis, the vertical one, you're going to change the x-coordinate to its opposite. So in a reflection, the original figure and its image are congruent, very important. Remember, they should have the same size, same shape. That's why we talked about congruent figures ahead of time. So take a minute to write this down. It's not that much information. Okay, so you do not have to draw these. Okay, kind of like yesterday. We have a few that you need to draw and a few you don't. Okay, so it says tell whether the shaded figure is a reflection of the non-shaded figure. So back here is a picture of what it looks like to be reflected across the y-axis. Notice this flips over the top of the y-axis, and our A is the same distance away from y on both sides of the y-axis. Our C is the same distance away from y on the appropriate side of the y-axis. Here, if we're looking here, this flips over the x-axis here, and it's like A is the same distance from the x-axis on both sides, C is the same distance from the x-axis on both sides, and B is the same distance from the x-axis on both sides. So we're looking for a flip. So if we look at these figures, okay, did this figure right here just flip over this line? Well, no, it turned, it rotated. Okay, it turned on its side. So it didn't flip. What about number 2? Did this flip over? Did this part end up here? Did this part end up here? I always look at one point. So if I look at the top of this point, it should be flipped so that it's facing the other way. Well, yes, this did flip. Okay, what about number 3? Look at this point. If this had flipped, where would this be? Well, it would be up here. So this is just a translation. It just slid down. So no, just slid for a slide. Okay, and last one, we have this one here. Did it flip over the top here? In this case, it does look like it did. It could have slid as well, it kind of seems, but the figure is kind of congruent and symmetrical, so we're going to assume yes, it did flip over that line. Okay? Again, you don't have to draw these two. I'm just going to talk about them. Did the blue figure, tell whether the blue figure is a reflection of the red figure. Did this one flip over this line? So your point here should be your point here, and then so on and so forth. It does in fact look like that would have flipped over the line. What about here? Did this flip over this line? No, because they would be facing each other, right? this would be the arrow going that way if it flipped over that line. So this is no. It just did some sliding action. Okay, so you do have 3 you need to draw. These 3 you need to draw, and you need to determine, did these flip, or are these a reflection? Okay, so try 1, 2, and 3 on your own. These are the ones I should see drawn in your notes. Our code word today is going to be success. So make sure you have that in your notes as well. Alright, so now we're actually going to go ahead and plot some points and then reflect them across the x and y axis. So, for the first one, -1, 1. Now, I think some of us were struggling a little bit with just graph plotting points yesterday. Remember, we always go to the right or to the left before we go up or down. Okay? So, if we have -1, that's telling us to go 1 to the left because it's negative. And then 1 in the y coordinate is telling us to go 1 up. So our point would be right here. This is A. Okay. Now B is -1, 3. Again, to the left 1, up 3. 1, 2, 3. This is going to be B. And then C, we have 6, 3. So to the right 3, up 3. Now we have this triangle. So, and this should be in your notes. You're going to need some graph paper. Okay, we are going to reflect this across the x-axis is what it's asking us to do. So, I can figure out my points right away. If my points, my original points are here, and I'm reflecting across the x-axis, if you look back at your notes, back to this slide, it tells us if we're reflecting across the x-axis, we change our y-coordinate to its opposite. So all I'm going to do to find A prime is change my y-coordinate to its opposite. So if it was 1, it's going to be -1. If this was 3, it's going to now be -3. And if this was 3, it's now going to be -3. All I did was change all my y coordinates to their opposite. It does ask for the coordinates, so it's good maybe to start this way, even if you can picture it flipped and you kind of know what it would look like. Now I can go ahead and say, okay, A prime is going to be -1, -1. So that would be here. Is this the same distance from the x as this? Yes, it is, so that's good. It does look like we're flipping it. B is going to be -1, -3. B prime. So is this the same distance from here as it is from here? Yes, that's a good thing. And then 6, -3. Same thing with C prime. Is this the same distance as this? Looks set to be true. So our reflected figure across the x-axis should look like this. Then you can kind of look and see, does it look flipped? It does. Good. Let's try another one together. So the vertices of the quadrilateral are P -2, 5, Q is -1, -1, R is -4, 2, and S is -4, 4. It says draw the figure and its reflection across, or in is the way they put it, the y-axis. So this time we're going with the y-axis. So -2, 5 goes here. -1, -1 is down here. -4, 2 is here. And -4, 4 is here. So we got an interesting quadrilateral here. It's going to look something like, try your best to draw straight lines. Something like that. Okay, and now we want to reflect it across the y-axis. we're going to take our points here. We have P negative 2, 5. Q is negative 1, negative 1. R is negative 4, 2. And S is negative 4, 4. So I want to find P prime, Q prime, this R prime, and S prime. Okay, so if I'm going across the y-axis, I'm actually going to change the x coordinate to its opposite. So negative 2 becomes 2, negative 1 becomes 1, negative 4 becomes 4, and negative 4 becomes 4. So now we have our new points. So let's look at this. We have 2, 5. This would be P prime. It does look like it's the same distance across the y-axis. We have 1, negative 1. It does look like it's the same there. We have 4, 2. And we have 4, 4. So there we go. Does look like it's the same there. Alright, so you have one to try on your own here. It wants you to plot these points, so it is a rectangle, and then reflect it across the x-axis, and then reflect it across the y-axis. So I need the points, and I need the picture of it reflected across both. Checked. Once you have that done, you can come show us your homework. We'll give you your worksheet for the day. So make sure you look at this. You do not need to worry about this part, but the answer would be yes. Have a great day.